Hello guys, this session is CATIA Parametric Modeling sessions, and today's content is this tetrahedron shapes. So there's some of the way you can achieve this model. It will be a good practice before watching this video. You imagine that yourself or test yourself to achieve its goal. So here's today's, I will introduce some other way to achieve this model. Okay, so let's get started. So first method, before we start the method, usually since we want to build a parametric model, we always want to change the location and position. So the standard locations, we usually don't use these since it's presetted. So we want to build our own way, always. So for example, we want to change the location anytime. So just for example, so there's some point somewhere. So this is the point, center point. Okay, then maybe we want to build the directions, z directions. So some around something like this. Then maybe also we build the plan, and we're going to creating the sketch, and the sketch you should set this projection point. So this point will be always follow the sketch as a sketch origin. Then we create the let's say we're gonna create some rotations from the horizontal line. So these rotations I want to use as origin of the x-axis. 100. Okay. So now we have x-axis and the z-axis. So we want to rotate s-axis with the z-axis 900. Okay. So in this way, you can define your own axis system and the locations. So this is y direction and this is the x direction. So just always make it once this like this. You can create as a power copy, so you can use anytime, anywhere. So once you define, you can change the location, and all your model will follow your axis system. Okay, so it will be avoiding the errors when you're using those, and you wanna move something. Sometimes you will encounter the errors. Okay, let's get started. Then the first method. Okay, let's say first. So it might be one of the easiest way. So let's create the cube. Okay, so cube. So we will extract from the cube, creating the tetrahedron. Okay, so we're going to sketch here, and projection point should be here. And now orientations is the parallel to line, the x-axis. Okay, so here we're going to create it in the center, and here this length, let's say 500, and this length also 500. So we want to control this size. So we're going to create the parameter later. Then also, well, let's just create the volume for now. We're going to use the sub element. So this should be a 125, 250, something like that. Or you can also use this since it's symmetric. Okay. Now this volume is we using as a reference, so this will always there. So since we're going to use the sub element, okay, we don't wanna delete anyway. So that 500 we want to fix it, so you can create the here parameters length. So parameters will be here. So since it's there's some different ways, so we're going to creating under here. I just copying it, and you can create another geometrical set, and I will change it out order. Okay, then this one we call this size. Okay, so 500. Okay, so we're going to link. So this one with formula, double click. Okay, same as this length, double click and click the double click the parameter that you want to link. Okay, and now this one also go here and the right click, edit the formula and double click. Yeah. Okay. Should be device 2 here. Okay, here we are. So now I just hide this, and this oops, this will hide the 2 and here. Okay, then for understanding better, I will creating it transparency a little bit. Okay, then now let's create tetrahedron. So once you click the corner and this corner, okay, then okay, and also you click this corner and this corner, click OK, and this corner to this corner. Okay, now another place, creating here to here. Then this you can see the triangle, so here to here. So in this way you see the size of this line will be same, since we're going to use the cube. So the last one will be here. Okay, so now I'm going to hide the cube. Here we have. So this is the first way. Let's just finish. Maybe we can make a fill. Okay, here you are. So we'll have the shape now. Then just finalize, create, join all everyone together and here. Okay. So this is the shape, And when we want to change the size, always check that while even modeling if still works or not. And now when you have the relations here, we want to put it inside of this geometrical set. I Ctrl C and Ctrl B. Okay, and I'm gonna delete them. The formulas you can activate here. So this will still will relink them. So let's say for 300. So it works well. So per check, measure item. So this the length is all same. Okay. Okay, let's move on the next method. Since you know the length, for example, we want to control the length, not by the shape of the cube, right? So because this is the in the middle line. So let's move on the next method. Okay, so let's look at the second method. The second method, we want to control the edge length. So we will going to creating them from the bottom triangle. So I will just copy this and delete all of them. Just for keep it the parameter and the sketch. And this sketch, we no longer use this rectangle as well. So what we need is creating the polygon here, and we need to have a triangle shapes here like this. Then we define by the length, like this should be this parameter. Good. Then now okay, that's finish. Then now we want to create the line here. So we want to creating the plane because we want to sketch here. Then we sketch here in the plane. Origin should be here. Orientations parallel to this line. So here we have. Then now we're going to create into this line. Remember that all edges should be the same length. So we're going to create this length parameters with this size. Okay. Then we need to coincidentate with this edge, and it should be the this V directions matching here. So this point and this V direction should be a coincidence. Okay. So now here. So so we need to rotate them. So rotator, let's rotate this one as a minus 200 and copy again the 200, 100, 200. So now we have it like this. So let's just check the size. So this size, that must be all same. Okay, so this is the second method I can introduce. I also move this one, we'll delete and deactivate again. So second method, hide here. Then lastly, I will create another method. We're going to use some kind of a geometrically and mathematically using the characteristic of this tetrahedron. So defining, if you remember this line, actually if we can creating from the start this line instead of creating this bottom rectangular bottom triangle, so it would be faster and it will be a good logic as well. So let's do that. Third, so imagine that we are going to creating this line from the center of the point. Okay, so so we need to imagine that this profile. Okay, this profile, this is the length, and this is not in the projection view, not the same length, right? This and this is not the same, but this is the same. But when you're creating remember that when you're creating the triangle, we use this method. There's a outside the arc and inside the arc, right? So if you think this is the in 3D, this should be the square, outside of square and inside of the square, right? So we use this the methodology in the vertical direction. Okay, so vertical direction, and this point will be the inside of the circle, and this point will be the outside of the circle, right? So we're going to create them from here, right? So just I will hide this. Seems we should better to have more the plane here instead of using only the XY plane here. So here we created a more standard planes. Okay, so let's use this one. So here going to copy the only parameter and the geometrical set. Okay, so sketch in this plane and project point and the parallel to line. Okay, and I want to change the directions. Okay, good. Now what we do, we're creating two circles, 1 and 2. Okay, then first line around from the top to bottom around here. Okay, then this will a little bit smaller around here. Then here you create the parallel line like this. Okay, then we're going to delete this one, and this one should draw the center point, and this line we're going to match this in the middle. Okay, so we're going to create this and this should be perpendicular. Oops. But then also this should be the tangency here. Okay, then now the size or fixed, only you can move only one. So we define this line with this parameter. So most of our change it to the constraint element. So for creating this line, you can use like geometrically calculate the mathematics, the angle of this line. Okay. Then now we only have one. Then rotate. So 120 and rotate again the minus direction. And now you can connect them between the line to line. Okay. Then just for check, let's try to measure again. So this length are all same. Yeah. So this is third method. So there's many different ways. I wonders how was you defined this shape. So it will be the good practice. So thank you for today watchings, and have a good weekend. Bye bye.